Have you ever heard about a scenario that Netflix has gone down just because of one upgrade, or Amazon went down because of any batching or any component upgrade? No, right? This is where this architecture decision comes into picture. Usually, up to last 10 to 12 years before, we are following one architecture that is it's called the monolithic architecture. We are keeping all the repository together. Whenever there is an upgrade or any service upgrade or patching required, we need to bring down the system completely, and then we need to update those components, and we have to go ahead with all the testing and all. Later comes another strategy in this system design altogether, or system architecture altogether, that is called the microservice architecture. In the microservice architecture, all the services will be decomposed into different sessions. Each service will have its own databases. Each service will have its own API interfaces and all. So that whenever I need to upgrade something, or I need to update some application, some part of the application, suppose if I want to update something related to order page, I need to go ahead and update only the order page related repository. I don't need to bring the entire services down. This is what monolithic versus microservices. Today, we are going to see what are the differences between monolithic and microservice architecture. What are they? What is meant by monolithic architecture? What is meant by microservice architecture? Let's go ahead and see one by one. First of all, we will see what is meant by this monolithic. Okay. Monolithic. Monolithic means, suppose I have user related modules is there, and I have product related modules are there. Then I'll be having around order service. Okay, in monolithic services, we'll be having a single repo. It is bundled together. Single repo which is bundled together, and it will be connected to a single database. To be having a single database, which is a very huge schema. There is a lot of dependency and all. This kind of architecture we call it as monolithic. That means everything is interconnected within the same repository. Everything is interconnected within the same repository. Whereas it is very difficult to manage. It is simple to um, keep everything in one place, but it is very difficult to do any deployment. Here there is only one deployment. Okay, one deployment. There is only one deployment. Whereas when come to microservice architecture, we have user comes into picture. Okay, user will go to the API gateway. There comes to the microservice. Microservices means each and every service. This is user service, so we can consider it as a login. Login service. Once it is logged in, we will get this API gateway. Through this API gateway, we will be having around user service. Okay, then we'll be having product service. Then we'll be having order service. Okay, these will go to communication, will go to each and every services separately. Okay, I don't need to worry about one service to communicate with each other. Internally, these services are connected together. User services have its own DB, user DB. It can be a Postgres SQL, and product is having its own product DB, order is having order database. That means all the services has been decomposed into its own layer. Suppose if I want to do any deployment, here we have around three independent deployments. Three independent deployment. Suppose if I want to make any changes in the user service, only this user service component I need to redeploy. Okay, if there is a change in this product service, then only this products related service only I need to do the changes and redeploy. Similarly for order service. This is what this microservice architecture all about. Okay, now let's go ahead and see what are the communication protocols used in this microservice architecture. Okay, communication protocols. When suppose if a user login, then he will be requesting to some of the API. It will be some user page, or it will be some order, or it will be some product. Okay, so it should be this communication will be happening through REST API. This is happening to REST API. REST API. It is happening to REST API. Once it is done, it will go inside the microservice layer. Okay, down the line it is micro service layer. Inside the microservice, I have this user service, order service, and product service. These services will be communicated internally through gRPC protocol. gRPC protocol. Within the microservice architecture, the communication protocol used is gRPC protocol. Once it is done, then the communication will go and fetch the underlying database or underlying services. Okay, underlying DB communication. DB communication and all. Here we have created, in this layer, we are creating some events. We're creating some events. Events in the sense either it can be some user related events, or it can be a order, or it can be a product events. Okay, to transfer these events, we can use another communication protocol or service. We call it as Kafka. Okay, Kafka is a message queue system. What it is doing, what are the event which is happening in this system, we can call these layer, these are all producers. Okay, these are all creating, these are all producing different events. It can be user service related events, or it can be order related events, or it can be product related events. These events, let's forget about this DB communication at this moment. We can consider it as a message queue or event driven system. Okay, using Kafka. All these events will be queued. It will be queued. And this message will be consumed by whom? This message will be consumed by consumer. Here comes this producers. Here come the producer. Here come this event-driven system by Kafka. Then come to this. Okay, now all the events has been pushed into the Kafka. Now Kafka will give all these events to the respective consumers. Okay, consumer groups. Who are the consumer? Either it can be given to the database or analytics team. Okay, etc. It can be feed to different databases. The user details will go to the user databases. Product related details will go to the product databases. Order related inquiries and other details will be go to the order related databases. And these queue can be used by many teams across order team or database team or analytics team for further analysis and all. And these are called the consumer group or consumer group. They will consume the data which is coming from Kafka to the consumer level. To consume and process the data for the next level. This is how this communication happening within this uh, microservice architecture. Three different level. One is REST API we are using, that is for communicating at the first stage of communication. Inside this service layer, we are had service decomposition. Each service will be decomposed into different microservices. These services will be communicated internally through gRPC protocol to reduce the latency. After that, this what are the message which is coming, it will be transferred to the it will be converted into events. These are called the producers. Why we call it as producer? Because we are passing this information to this event queue system using Kafka. Kafka will take all this event from the producers and it will go through it will be saved in the broker and then this message that is in the message queue will be receiving the message queue. These messages will be consumed by the consumer group. Consumer group can be any system which is consuming this data. More than one consumer can access the same data or same data in the message queue. Suppose if it is need to be saved in the database, it will go to the database consumer, or it is analytics team, and it will go to the analytics team queue and team consumer group. This is how it is happening. Let's go ahead and see these things visually and then we'll discuss there later. Okay, so this is the architecture about this monolithic and microservice architecture. Okay, in monolithic, it is a single deployment unit. Here we have user module is here, product module is here, order module is here. All the modules in a single deployment. Okay, they have a shared database. We will be having a single deployment. Whereas in microservices, we have user service, separate user service, we have separate product service, we have separate order service. All of them are connected to from user service to product service. It will be REST. From user is sending some request to either to the product service or order service or any other services. That will be through REST. After that, inside this microservice, we have this gRPC protocol for fast access and reducing the latency. All this will be creating some of the other events. Events will be captured by the Kafka service. Or it is called the event bus. Okay, this is about monolithic architecture. The client will come and hit the browser. Once it leaves the browser, it will be go to the monolithic deployment, a single deployment unit, one process, one code base. Okay, as we have the presentation layer, REST control, HTML views and all, business logic, user, product, order, service, everything is coming into the same single code base. And then we'll go to the data layer, single shared Postgres database or any other databases. Everything is in a single bundle manner. Then let's go ahead and see this microservice architecture. Microservice is a small independently deployable services. All the services will be decomposed into different separate repositories altogether. And each repositories will be handled by separate team. They don't have the dependency with the other team. And each services will be having its own endpoint, API endpoint. And through that API endpoint, they can communicate each other. These API endpoints are connected together using the gRPC protocol. and each owning its own data, API contract, and CI/CD pipeline, and also it is having its own databases. Independent scaling per service, technology hierarchy, technology heterogeneity, team autonomy, and for isolation. If you see here, here we have this client. From the client, the communication will go to this API gateway. Here we will be having this authentication, rate limiting, and routing. Now this API layer to the user service, it's a Rust API, and then here also it will be REST API, but internally within these services, user service to product service to order services, and all this communication is happening through gRPC, so that the network latency will be very minimal. And user services have its own databases, product services have its own databases, and order services have its own databases. And once it is done, it will go to the Kafka event bus. What are the event which is getting generated? It will go to the event bus, and from the event, other services. These are the communication protocols used. Sorry, these are the consumer group. Either it can be email service or inventory service or payment service or analytics service. These are all another consumer group. They can consume this Kafka event data for the further processing. Then let's go ahead and see the comparison between this monolith and microservices. Deployment is a single artifact. Here in microservice, it's per service CI/CD pipeline will be there. Database in monolith is a single shared database, whereas in microservice, it's a per service. Each service is having separate databases. Scale. We need to scale the entire application. Here we can scale individual services. Suppose if there is any huge requirement for the orders, and then order service can automatically scale up. If you're using Kubernetes deployment and all, it will do the HPA, horizontal pod auto scaling. Using that one, it can horizontally scale whenever there is a huge surge in any of the service layer. Communication, this is in process call, whereas in microservices we are using Rust. We can use gRPC and event bus. Failure scope, if there is any failure happening, this in monolithic, it is going to fail the entire application, whereas in microservices, uh, failure of one service is not going to affect the other services. Tech stack, it is a single language. Microservices, we can use different languages for different deployments, because outside that service layer or decomposed service layer, the communication is happening through API endpoints. So it is not going to affect the internal language which is used to develop this application. Then let's see the decomposition. If you see the service decomposition, user service, product services, and order service, they have different API endpoint. Okay, split by business capability. These services are split to each other using this business capability. User service, so what are the user related service? Suppose if it is a post service, it is going to do some authentication login, authentication register, or user ID. You need to get the details of that particular user ID. That is for getting. If you need to update or create some, you can use put API endpoint for that particular user ID. We can use PostgreSQL Redis for caching in the sessions. Come to the product service. Product service, if we need to get the product, we can get the get. And that is we can go, fire the query to the product API endpoint. Suppose if it is a particular product ID related, then we can give the product /ID. Each endpoint is going to generate its own URL. In order service, we have the cart, checkout, and fulfillment. We can use post, get, and all other API endpoint for cart. So what are the principles? What are the decomposition principles? That is bounded context. That is each service mapped to a business domain. And database per service, each service is having its own databases, so there is no interdependency between the database. Then independent deployability, that means each service can be deployed independently. We don't need to worry about the other service deployment. Smart endpoints, dump pipes, that means we have a separate endpoint for each of the service layer. And we can see what are the communication we are using. We are using HTTP or JSON using Rust API. That is synchronous request response of HTTP. Then inside this microservice architecture, we are using gRPC protocol. And event driven, that is using Kafka. If there is any, there are different events are getting generated by each of the producers. Those will be communicated using this Kafka architecture, in Kafka event driven system or Kafka message queue system. Okay, let's go ahead and see this in practical. I have created sample application to demonstrate this monolithic and microservice architecture. Let's go ahead and see. Let's go ahead and spin up this application. Okay, this is how it is working. This is the system design architecture client using REST API. It will connect to the API gateway using 8080 port. Through REST API itself, it will be connecting to internal services, that is user service, product services, order services. These services are connected to the using the gRPC protocol, and then the events will be given to the Kafka message queue system. The Kafka will be given to the event consumer. This is, let's go ahead and spin this application. Let's bring this Docker service up. Run this application. Okay, now this mono versus micro Kafka and zookeepers are up and running. I have spin up this Kafka cluster as a small application to demonstrate the difference between the monolithic and microservice architecture. Okay, so now these services are up and running. Through command line itself, we can see store all the services. Let's store all the services now. This is partial. It will run all the services now. Okay. Let's see what are they. All the services are coming up. Okay. This is first one is the monolith. Okay, single app I'm running on localhost 8010. Let's open this one. Okay, got it. Okay, this is the monolithic application Swagger API. If you see, we have all these endpoints are connected to a single API endpoint. If you need to get the health, if you need to get the user details, user ID, product ID, and order details, if you need to create any order, and all these services are connected together in single services. There is no API decomposition or service decomposition available in monolithic. Whereas when we see this microservice architecture, in microservice, we have different gateway for different services. If you all the API related requests will go through this API gateway. Let's go ahead and see the other gateways. Let's go ahead and see user related services or user services. User services. User services related to the health. We can see try it out, execute. We can see 200. Response is 200. It's working fine. And get users, we can see how many users are there. We can get the user details. We can see these many users are available. We can see all the user related details. Okay, then suppose if you want to get the particular user, that is user ID 2. Okay, then if you want to get the details of user ID, then user ID 2, then execute, we will get that details of that particular user. User ID is Bob Smith. Let's zoom a little. Okay, so these are the user service related endpoint. Then we'll go ahead and see product services. Let's see this product services. Product endpoint, we have product health status for each page will be there. For each service is a separate endpoint. So each microservice have its own health check. Try it out whether you will see whether it is healthy or not. Yes, it is healthy. 200 means service is healthy. Then close the health part. Then we can see the product details. And we can see executing, we will get all the product related details. USB-C hub, mechanical keyboard, wireless headphones, and it is going to give all the product related details, and it is not going to show anything apart from the product, anything related to order, anything related to the user. These are all not going to display the um, product related services. Why? Because product services is having its own databases and it is having its own endpoint. This is not going to deal with the user services. Similarly, user service doesn't show any of the endpoint related to product or order. Why? Because it is having its own database. This is pulling all the details from the underlying databases connected to user service. Let's go ahead. We have one more endpoint is there, that is called the order service. And in the order service, you'll be getting all the services related to order. We have the help page. We have the order. We can get all the order related details. How many orders are there? All the details we can get. As of now, our response body is empty. There is no order is there as of now. And that is order. We can put some order. We can get if we put some order. Let's see. Try it out. Okay. User ID 1, product ID 1, quantity 2, execute. It is going to create a what? It has created one order. And let's see this order ID. If we want to get the details of the order, we can execute this one and see any order is our yes. We have one order. We have just before we have put some order, that order is listing here. It is a confirmed order. And we have seen this order ID. If you have the order ID, we can get the details. Let's see whether it is order ID. Where is order ID? ID is 1. Order ID is 1. Let's get the orders and try it out. Order ID. Execute. It will give the details of that particular order. It's a confirmed order. What I mean to say is, if you are following the microservice architecture, this is going to segregate each and every services separately. Order related services together. Suppose if I'm going to bring this order related services down, it is not going to affect the other services. Okay, so let's go ahead and see whether that is included here. Create order, show microservice gateway. We have different terminals. Let's find out which one is related to order. This is monolith. Don't worry about that. This is API gateway. Let it be there. Let it be there. This one is related to what? This is order. This is order service. Product service. Okay, I'm going to stop this one. This is the product service. I'm just going to close this. Now the product service is stopped. Now then we will go ahead and see this products later. API gateway is fine. User service is fine. Product service. Let's refresh this page. It will not be available. Whereas the remaining services are working fine because these endpoints are working fine in the backend. This is the beauty of microservice architecture. Okay. If the order related service endpoint is down, it is not going to affect any of the other endpoints. Any of the other endpoints will not be affected. That means the overall system will be up and running, even though one of the service is down. Whereas in microservice architecture, monolith architecture, let's see this maybe the last one. This is no. Let's go ahead and find which one is order. Not this one. Not this one. API gateway. I think this is. Suppose we have this monolithic architecture. It's only a single health point, health check for the entire system. Right, or it is executing. The system is healthy, and we have the user related details are there, product related details are there, and order related details are there, and all the endpoints are in a single Swagger API. Why? Because these are all connected to the single backend shared databases. Suppose if I bring this monolith service down, I have stopped the monolithic service. Now, if you see, that complete application went out, will not be able to access any of the services now. That's the beauty of microservice architecture. Even though if one service is down for maintenance or something, it is not going to affect the entire other application. This is what about this monolithic versus microservice architecture. This is the practical example. If you go ahead and see example of Amazon e-commerce website, let's go ahead and see what are the system components. Okay, in the edge devices, we have this CloudFront Route 53 and web application firewall. From the client side or browser side, we'll be first we will be hitting on this side, that is the edge point. From there, it will go to the gateway system, that is API gateway, automatic load balancer, Cogito. From the gateway, this communication will be transferred to the internal service layer, that is microservice architecture layer. It can be user service, product service, inventory service, cart, order, or payment. These are all different um, microservices. And from the microservices, it will be generating different kind of messages, and it will be passed to the message queue system or event driven system. Either it can be done using Kafka, a message queue system, SQS, SNS, or Event Bridge. That depend upon the next end point, how they are going to access from which endpoint. Then it will be given to the DynamoDB or a Postgres DB or Elastic Cache, or it will be served to the S3 search, or it will go for the open search for the product catalog at all. Finally, we'll be giving all this data to this machine learning and analytics team for data analysis and all. It can be AWS SageMaker or pricing, fraud detection, against add-on. These are the architecture of a basic microservice architecture. Okay, so this is all about monolith versus microservice architecture. Thanks for watching this video. See you in the next one. Bye. Have a good day.